All right, great. Thank you. Thank you for attending Griffin's Cannabis Online Workshop. First, a word of thanks to our sponsors. They've helped make this the educational series that it has become. I'd like to read them off by name. Agdia, Anderson Injectors, the team at Premier that gives us ProMix, Lalamond, Plastica Cretus, Verano 365, and Bioline AgroSciences. Our 5-part series connects with improving efficiency and profitability in cannabis cultivation. Our goal for today's webinar and the entire series is that you learn about innovations and strategies that you can implement immediately or in the near term that can move the needle for you and your team. Today, we have 2 presentations for you. The first is by Colin Walsh, Agdia's Director of Marketing, and he'll be presenting on how early detection saves crops. The second is by Andy Peterson, Verano 365 National Sales Director, and he'll show us how by utilizing their new product, Evo Factor, you can reduce crop time and improve yields for real. I'm sure you'll find both presentations to be very informative. And as an attendee, you will receive a link to the recording of this webinar. Feel free to enter questions into the chat at any time, and we will do our best to get them answered during the session. And if not during the session, then you will certainly receive an answer through email. With that, Colin, the screen is all yours.
Thank you, Greg. And thank you, everybody, for participating today. As Greg mentioned, the title of my session today is Early Detection Saves Crops, particularly with cannabis pathogen testing. Just to be clear, this is pathogens that are affecting quality and yield of the plant itself versus more of the compliance side, human pathogen type testing. So just to be clear on that. So first, a little bit of an introduction up front. First and foremost, I'm a husband and father to 3 kids under 4 who keep me very busy at home. Growing up on a little bit of a hobby farm myself, my wife, my kids, and I grow vegetable crops for ourselves, our family, and our local farmers market. So that's always been a little bit of a hobby of mine. And then leading into my regular day job here at Agdia Incorporated. We were founded in 1981 in a basement. So a little bit of the history of the family-owned company. The founder, Chet Satula, and his wife, Jane. Chet used to work at Bayer here in Elkhart, Indiana, working on diabetes diagnostics. And so working with a couple of folks here in the US as well as the UK, they had heard about some problems that were occurring in the potato industry as far as different potato pathogens and viruses that were out there that were causing a big problem for yield and quality of potato crops. So Chet took the existing technology of the time that was only in human diagnostics and kind of helped bring it over to plant pathogen diagnostics, and that's how the company got its start. And then it's just kind of grown over the years. So pretty much we're going to cover any area of agriculture, horticulture, any crops associated across the board. Fast forwarding kind of to today, we have test kits for about 200 different plant pathogens as well as GMO traits in various crops. And so let's jump right in real quick to an intro on plant pathogens. So why are plant pathogens a big deal? Well, you have a bunch of examples through history, starting with fossil evidence about 250 million years ago. You have different rusts and mildews that are mentioned in biblical and ancient Greek writings. But for a good idea of a true impact of that, the late blight, which was caused by a water mold that caused the potato famine in Ireland that wiped out a good portion of Ireland's population. And then fast forwarding today, various diseases you have. Fusarium is a big problem with banana crops right now. It will probably wipe out the current banana that we've come to know and love. And they're furiously working to come up with a new resistant variety so we can continue to have bananas at the grocery store. But really across the board, the point is that Plant pathogens really have a big effect on everybody, whether or not we know it. And then fast forwarding to today, on the top there, the $220 billion number is what the FAO estimates as the global economic impact of plant pathogens. $4 billion of which in the United States alone in cannabis is estimated to be the attributable losses to hop latent viroid that we'll dive into a little bit later. From here, the first thing we're going to do is we're going to dive into the tomato industry, just to look at an example to try to set a heuristic, a frame of mind of how to approach plant pathogens and protecting your crops generally. There are a lot of things that can be mapped over from other industries into cannabis production. Then we'll dive into cannabis pathogens, just a quick overview, look at hop latent viroid in more detail, and then going over different strategies you can use to both prevent and monitor for plant pathogens. So to jump into the tomato industry, my plant pathogen colleagues would tell me I'd be remiss if I did not talk about the disease triangle. So what we're going to use here is tomato brown rugose fruit virus is a very devastating pathogen that was discovered, I think it was around 2014 over in Jordan. It has since spread to all parts of the world. It's considered a quarantine pathogen in many countries, and there are a lot of export regulations surrounding the trade of seed. And so diving in a little bit more, what is the disease triangle? So the disease triangle is just a way to look at the three core areas that have to be present for disease to take hold. Number one is a host. In this case, we're just talking about tomato. As a tomato producer, your host has to be present. You have to also have the pathogen present. And so in this case, tomato brown rugose fruit virus can come in as a pathogen through seed. It can come in through grafted materials. It can carry over on dead materials from previous crop cycles. And regular testing is very important for that purpose. So now that you have a host and a pathogen, that does not necessarily mean you have disease yet. You have to have the right environment for that to occur. So you have to have a means of that disease to propagate throughout a given environment. In this case, you can consider like a greenhouse. If you're trimming, if you're pruning your plants, that can carry over on your pruning your cutting tools from plant to plant. And that's one way that the environment can help to introduce that pathogen to that host. Just a quick overview of what and how impactful this virus is. Tobacco mosaic virus is something that's spoken about in the cannabis industry a little bit. That's something that was a really big problem for all tomato, pepper, and eggplant production for a while. They worked very hard over decades to develop resistance genes to tobacco mosaic virus. And the newer one, the TOBRFE, is a related virus that has overcome all of those resistance traits, and that's why it's become such a big issue all of a sudden. It's a very virulent pathogen. It can go throughout a facility very fast. It renders all the fruit of an infected plant unmarketable, costing a lot of money. It's a very stable pathogen, and it's easily transmitted. And this is something that we'll talk about a little bit with another parallel with hop latent viroid in cannabis. There are a lot of trade regulations involved here, so the stakes are high when it comes to keeping your crops clean. And so the next steps are, if you are deciding to test on site as a grower, a tomato grower for TOBRFE, what options do you have? And this is going to apply also to other pathogens and to cannabis, regardless of the crop you're using. This is a good way to kind of look at the tests that are available. So on the left-hand side, you have an ELISA-based method. An ELISA-based method is based off of an antibody detection. So an antibody has to see something that it physically can bind to, such as the protein coat, the protective protein coat that's on a virus. So those plates, they're like 96 well plates that are coated with antibody that help to recognize the pathogen. This sort of test takes several hours to days to complete. It's cheaper but more labor intensive. The next up is the immunostrip, or a lateral flow device. And so all that is going to be what you'd commonly recognize as like an at-home COVID test or a pregnancy test, the similar format. So in that case, you're taking a leaf, a root, a seed sample, In this case, you're putting it in a bag that will be pre-filled with a buffer. You're grinding that sample up, and then you're simply taking that test strip, putting it in the bag. The sample runs up the strip, and it'll give you 1 line if it's negative and 2 lines if it's positive for that given disease. Another one that a lot of people are going to be familiar with is going to be PCR or qPCR. So both the Immunostrip and the ELISA on the left-hand side here are the antibody-based tests, and the 2 on the right-hand side, whether it's the PCR or the rapid molecular, more portable type of PCR, are going to be based off of the test being able to recognize a genetic sequence in the genome of the pathogen. And so at PCR, qPCR, kind of similar to ELISA, there are quite a few steps involved. Some of them are easier than others. It involves pretty expensive equipment up front and has quite a high level of all the ones here, probably the highest level of training that will be required for a technician or scientist to run that test. Finally, the amplifier P method on the right is kind of a simplified portable version of a PCR test, where same sort of thing. You take your sample, you grind it up in your bag, and then you take that sample out of the bag with a pipette, for example, dilute the sample in a buffer, take that diluted sample and you'll add it into the reaction pellet, which is kind of like your PCR primers, for example. And then you can either take that and put it in like a portable unit, like this portable battery operated amplifier here, or you could also use it in a qPCR machine, and that test will give you the readout of a positive or negative test in 15 minutes. And so that's just a kind of quick, semi-hands-on overview of how these tests work. And then we'll go in and categorize these in 3 different ways. So a few categories based off of what is the capability of the test, what can it detect? Then the next 2 categories really can't be separated from each other, function and cost. You kind of have to look at those side by side when you're determining what is the best test for the context that you're in. And so let's looking at this from TOBRFE, for example, it is a virus. So being a virus, as you can see here on that top line, any one of these technologies will work. So depending on what you're doing, where you are in the tomato production line, you can kind of choose for yourself what you want to use. So in this case, we can move on to the function, and then the function really depends on, again, your context. So let's say you are a seed producer. And so since, as we mentioned before, there are a lot of regulations surrounding the trade of TOBRFE, you're narrowed down in what you can use to test for that, at least as it pertains to the export of seed. And so in this case, a lot of the seed producers will use the ELISA plate as an initial test, and then they have to use, due to regulations, a particular set of qPCR tests in order to be able to trade their seed into other countries.
Colin.
Yes.
I'm going to interrupt just quickly to try and do a sound check.
Sure.
If you're having trouble with sound, could you please enter a chat? We have one attendee that's indicated that they've lost sound. I'm hearing you loud and clear, so I want to see if we've got a situation out there that may need some help. Okay, it looks like I'm getting information that could be isolated, that there is not a problem with sound. Okay, unless I see something else, let's continue.
Okay.
Thanks.
No problem. Okay, so we were talking about seed producers and the tests that they will typically use. Now, further down the chain, if you're a tomato vegetable producer, our customers in this area have found that they would prefer to use tests that are easier to use, easier to train on in case of employee turnover, but then also that they have a quick time to result, a much faster time to their result, so 30 minutes or less. And so that's kind of what the type of test that they have gravitated towards in the greenhouse mixed light production space when it comes to tomatoes and peppers. Okay, so let's head back over into cannabis pathogens now. So there are quite a few different pathogens that are either known to or experimentally have been shown to be able to infect cannabis. Some are more well characterized than others. Many people here will probably be familiar, of course, with powdery mildew or various damping off or root or um, crown rot due to, let's say, fusarium or pythium. Those are also pretty well known, but really what we're going to focus on here to use as an example that can be mapped over to other pathogens further down the line is going to be looking at the hop latent viroid specifically. So first principles, what is a viroid in the first place? So a viroid is a very, very small pathogen relative to a bacteria or a virus. It's typically a small circular piece of RNA, kind of similar to a virus, but one of the main differences is that there's no protective protein coat around it, and it's a much smaller genome generally, not much more than about 200 base pairs of RNA. So you have a much smaller target that you need to be able to look at to be able to detect it. So let's come back to the disease triangle here. So host we're looking at being cannabis, pathogen, in this case, hop latent viroid, and then the environment, so how it spreads through clones, spreads through tools. That's very well documented. More recent research has shown the ability of it to transmit through seed at various levels. And then there's research being done yet, but nothing conclusive about transmission through various insect vectors, such as rice root aphid and leafhopper are being looked into in that standpoint. I believe all they've figured out so far is that those vectors can carry the disease, but they have not shown whether or not they truly transmit it in real life. And so why is hop latent impactful? Why is it a problem? It's very challenging to identify it visually, and that's where diagnostics is very important, especially early on in the growth cycle. It's at a very high prevalence, depending on the study you're looking at. California has been shown historically estimated around 70 to 90% infection rate, at least as a couple of years ago. Hopefully that's come down a little bit since testing has become a little more common. Recent studies in Canada have shown, upwards of 30 to 50% prevalence up in Canada as well. Again, like we talked about earlier with the tomato virus, this is easily transmitted and very stable, so it's tough to get rid of. And then also at a minimum, you're looking at probably about 30% yield reduction from plants that have the viroid, which is not known at this stage to be curable in any way, much like a virus. So what do hop latent viroid plants that are infected with this pathogen look like? There are a lot of different areas, but the hallmark here is going to have short internode spacing, which results in kind of a Christmas tree, stunted looking plant. Lateral branching, a lot more branches are going to be a lot more lateral, less vigorous. They tend to be more brittle. And they think that's due to enlarged cortical tissue and reduced development in the xylem. And so what does that actually look like? We'll go through the kind of the whole life cycle here. I'm going to lean heavily on recent research by Dr. Zamir Punjar from Simon Fraser University. He presented some of this first at CanMed earlier this year. So if you look at a healthy versus an infected root samples, you can kind of, it's pretty easy to see there. There's no doubt that there's something going on there. You also tend to have a higher failure rate of rooting of clones generally from an infected plant. Moving into, it's not just the initial root development, but overall root growth. So the volume and length of roots has been shown to be far less extensive in infected plants relative to healthy, as you can see here in a couple of different examples. Moving on, it continues to be very visible in this case with another susceptible variety where you see that shorter, stunted kind of Christmas tree looking plant on the left-hand side compared to a healthy plant on the right-hand side. And moving on to the big problem here when it comes to yield at the end of the day, here are a couple examples of some very susceptible cultivars where you have healthy on the left, infected on the right. And you can see visually just a very clear difference there in your overall volume of your flower. Zooming in a little bit, you can see a very, very stunning difference on the level of the trichome gland, both the size and the volume of that. So that's, at the end of the day, whether it's cloning, rooting, veg stage to flower, all the way to trichomes, these are going to equal profit and yield problems. And so the earlier you can catch this in the cycle, the better, in order to not waste time on plants that are going to give you far less yield than healthy ones. And so now, what can you do about it? Number one is prevention, of course. Best thing you can do is just maintain the clean grow environment. Considering PPE, especially gloves when it comes to pruning plants, and then sanitizing surfaces, and various cut and trim tools. And so far, there's research going into a few different sanitizers so far as peer-reviewed research. Virkon S and I believe it's 10% bleach are the ones that are known to eliminate the viroid, to be able to degrade it. Again, there's research going into other compounds, but it's tough to kill. And so it's very, very important to maintain that clean grow environment. While prevention is best, inevitably things are going to slip through the cracks in some way, shape, or form, especially when you're introducing new genetics. So monitoring in some way, shape, or form, whether that is a testing strategy of you sample and send samples out to a third-party lab, or whether you choose to do in-house testing, it's just very important to set up some sort of monitoring program on a regular scheduled basis for hop latent viroid. And this can also be applied to other pathogens as well. So why test in general, and what is the impact of that? Well, aside from falling off the proverbial bike by having your healthy stock become infected by introducing untested genetics, here's a little more of a quantitative look at what that is. So again, going back to some of Dr. Punja's research, he partnered with a facility up in Canada to begin a testing and eradication program, which involved regular testing and immediate removal of any infected crops. And so you can see on the left-hand side of the graph there, you have, close to 35% positive rate that they were getting when they initially started testing. And then you fast forward to about 6 months later, and you're down to under 10% of prevalence of the viroid itself. And so that's just an example of really being proactive. This is something that, as AgDS, and for the past 40 years, we've seen this in other crops as well. It's the more you're monitoring proactively, the more you're going to keep that disease out of there, along with all the prevention strategies we talked about earlier. So, I always thought that was a pretty stark way to look at it. So now that we know kind of the impact of that, what do you want to do? Do you want to send samples into a lab? Do you want to test on site? That can be a big question for a lot of growers. There are a bunch of things to consider with that. How many samples would you be sending out? And so what is the internal labor cost to run tests in-house versus the maybe more expensive for the test per sample itself to send into a third-party lab? But it depends on what you want to do as far as that is concerned, and where you want to put those costs. And then turnaround time for results is another thing to consider. How quickly can you take action after sampling that plant in order to protect the rest of your grow? Something I would put out here too, while we provide test kits generally, we encourage people, even if they're buying our test kits, to keep both of those things online, keep both of those burners going, because it's important to be able to have a secondary method that's not the same method you're using to maybe confirm results every once in a while. So it's always good to keep both of those options open, regardless of which one you choose to do the majority of your testing through. Okay, so if you decide you want to do some in-house pathogen testing and to establish a program there, what does that look like? So we'll come right back here to what kind of tests you can use for hop latent viroid. First of all, capability-wise, this is going to be a little bit different than what we saw with the tomato virus, because a viroid does not have that exterior protein coat that a virus does. There's nothing there for an antibody to recognize, and therefore you cannot use either a ELISA or an immunostrip antibody-based lateral flow test to detect the pathogen. So you become limited to these molecular techniques that are DNA or RNA-based detection, RNA specifically when it comes to the viroid. And so, as we talked about earlier, this is something where you kind of have to make that choice between function, cost, portability, and time to result. These are all things you have to take into consideration. In some areas, PCR, qPCR test may be better. In other areas, a rapid molecular test might be a little bit better. So the majority of our clients who buy the rapid molecular tests are growers growing in either indoor or mixed light environments. Some outdoor growers as well will use that. There's a lot of, for PCR and qPCR, that's a lot more of the kind of high volume testing labs will use that because it can be a little more suited to that. But both of these technologies can be implemented. Just depends on how much, upfront money you want to spend, how much training you want to be able to do across the boards. That's something you kind of got to balance out for yourself and what works for your facility. So a little bit of a more comparison between the rapid molecular techniques. What we have is amplifier P here and PCR, qPCR. So the qPCR is generally it's higher throughput, or at least if you're looking at a high throughput instrument versus a portable instrument. Again, the portable tests, the rapid molecular test, can be used in those high throughput instruments, but most of our clients tend to choose the smaller portable instrument as it requires a lot less training. But again, either test can be applicable in either situation. We have labs using the rapid molecular, and there are some growers that may choose to utilize the PCR, qPCR. So it's something you got to take into consideration yourself as you're evaluating these options. As far as how we test, we mostly went over that before, as far as the techniques utilized. Again, this is those rapid tests that we have, the amplifier P tests, tend to be chosen. I think one of the main reasons that fits well with most of our clients is the training that's involved, or lack thereof. So the ability, when there's situations where there could be high turnover, to be able to train quickly and get up to speed and get a quick result. And then things can be scaled from there, or maybe send in samples again to a lab to verify every once in a while. A question that comes up frequently is when to test. And the important thing here, like we talked about earlier, is to front load that testing earlier in the process, so you're not wasting time on infected plants. So always test incoming genetics, prioritize mother stock testing on a regular basis, and also do, it's also good to do routine or randomized testing on the veg stage. Doesn't make much sense to do any testing once you're into flower. You're kind of too late at that point to catch anything early, and you've already invested a lot of time and overhead into that crop. And quarantine or removal of the infected plants is, again, something to emphasize here. How do you sample? There's a lot of different research that's been coming out. Most people were initially testing leaf samples, leaf or petiole samples. A lot of recent research has shown that the root, at least especially early on in the life of that cutting of that plant, is going to be the best place to test. Some of the Dr. Punja's research had shown that even if you, for example, you're pruning and you prune an infected plant, and then you go and you prune a healthy plant, that area right where you pruned is going to be able to test positive at first. The rest of the plant stays negative, at least for the first couple of weeks. That infection, that viroid, is traveling right down to the root system first. So when it comes to younger plants, testing root, or at least including root as part of your sample, is wise to do for younger plants, especially if you're testing new clones that you take off a mother plant. When it comes to more of a mature mother plant, and if you don't want to risk damage to the root system, or potentially introducing other pathogens to the root system through taking a sample, once you're along a mature plant, it's a safer bet to be able to just take leaf and petiole if you choose. You can continue to do root testing, but it's safer to do leaf and petiole in a mature plant than it is in a younger plant or a newly rooted cutting. How many plants to sample? That's an impossible one to answer, aside from you test as much as you can within your given budget. Now, oftentimes, this is a very wide range, but whether it's in cannabis or ornamental or other tomato growers, it may be somewhere between a 1 in 10% of your crop that gets tested over a given cycle. But again, it's hard to give a big number there. It's more complex than that, but prioritize testing early, test early and often at those critical control points, such as when you're taking a cutting, when you are about to introduce new genetics. And then beyond that, just set a regular program, a regular schedule to maybe do randomized testing every 2 to 4 weeks.
Colin,
Yes.
can you provide just a little bit more detail on the leaf and petiole samples? Are they two separate samples? Are they connected? I see the diagram there or the picture there with the circle. Can you just provide us and the audience with just a little bit more detail?
Sure. So the thought behind leaf sampling is easier as far as being able to maybe clip the end of a leaf off. Generally, with a lot of viruses, it's thought that you're going to have a little better chance of detecting it in the petiole tissue because that's where you're kind of everything's flowing through that vasculature there. Once you get to a mature plant, though, as long as you're getting from the vasculature, whether that is you could do a petiole only sample, you could do a like this diagram has somewhere between the petiole and all the where the leaflets are taking off from there. That was kind of that could be an ideal spot because of the concentration of the vasculature. But if you're going to be doing leaf testing, you can also just making sure that maybe you're taking from the midrib of a leaflet. That's another area that can be okay too. So there's not necessarily a truly a right or wrong answer. The diagram on the right kind of shows you another way to kind of reduce the risk of missing something that's localized by taking, instead of just maybe one sample from a plant, you could take 4 smaller samples from different areas of that plant. Maybe one's petiole, maybe one's leaf, maybe one's root, and combining those together. So it's really just trying to dilute out the risk of missing something that's localized.
Okay, I think this is a perfect time because a chat just came in asking this. What do you think about sampling from several plants, upwards of 8 to 10 samples, and homogenizing them prior to testing? If sample tests negative, all plants are cleared. If positive, go back and retest all plants that created the sample.
Yeah, that's something that a lot of our clients will do. We will typically suggest maybe no more than 5 different plants together, just because the more of those samples you add, the more of a chance you have of diluting out a very low titer, a low level or early level infection. But that's certainly something you can do. That's another way to kind of get creative with how many plants you cover. So you certainly, that's a common strategy for sure. It's just taking into consideration that for every additional piece and part you add in there from a different plant, you could potentially be missing a lower level. But that becomes less detrimental in a molecular test like we're talking about now than it would be in more of the antibody-based tests. So, but yeah, that's certainly something to do. And maybe something else to do is to continuing along the thoughts of randomize is, let's say this month you are combining a bunch of samples from a higher amount of plants. Maybe the next month you're doing more targeted testing of one sample, one plant. It's just a good way to mix it up, but that's certainly a valid strategy.
Okay.
Yep. Okay. Most of this is pretty obvious, but now what after you find an infection? Number one, quarantine the plants, and then you have a couple decisions to make. If you're still kind of getting started with testing, especially in this case, retesting is always a good decision to do. That's something that you kind of have to choose for yourself based off of how many tests you want to run, but just maybe going back to the same plant or that same homogeneous mixture that you took, just to confirm that was a positive. You kind of are inherently doing with that previous question, doing this already by, if you pool 5 to 10 plant samples into one, get a positive, and you go back to retest, that's kind of a retest in a way, even if you're going back to those individual plants. That's kind of a built-in confirmation right there. And then in most situations, removal and disposal is really the best thing to do as far as we know so far, unless you're doing research into resistance traits. Um, okay, so just to kind of wrap everything up here, number one, identify your pathogen risk. Um, even if we establish right now that hop latent virus is the most impactful pathogen out there in cannabis, you always want to keep going back, keep learning, keep seeing what the newest research is out there, because there are other pathogens that are out there. Eventually, hopefully, resistance traits will be bred into cannabis, and the viroid will become less of an issue. But there's Mother Nature always finds a way with different pathogens. So always keep an eye out for what's out there, reevaluate with that disease triangle, and establish a testing program that's going to suit specifically the needs of your facility, of your personnel, and what your goals are there. And then testing early and testing as often as you can within your given budget is something that's important. And one other thing I wanted to mention here too is there's a certain known um, cost of testing, that's for sure. That may cost you anywhere between $10 a sample and $100 a sample, depending on in-house versus sending out samples. But if you look at the fact of that you can have a 30 to 50% loss of yield, another question to ask is what is the cost of not testing? And so you can run those numbers yourself and see what that looks like. And that can maybe kind of help you set a budget as far as your testing or monitoring schedule is concerned. So um, aside from that, again, any questions that maybe didn't get answered, we can answer it afterwards. Feel free to reach out to me as well. Happy to talk anytime about testing programs generally. So thank you for your time.
Colin, thanks. That was great. I do have one more question.
Sure.
Let's see. So, is each test specific to a targeted problem, or are there more sweeping or widespread results that no, you didn't test positive for this, but we found that? Tell me just a little bit again, more detail about how the testing procedure works.
Sure. Let's say we'll do two parts. One is sending into a lab, the other is testing on site. So if you're sending into a lab, you may ask them and they may offer a service just for hop latent viroid testing that will be just for that one pathogen. Other labs will put together a panel of known cannabis pathogens that will obviously cost more money, but you'll be kind of protecting yourself against a whole plethora of tests that are out there in cannabis. And so if you're doing that on site, that just kind of comes down to looking at what are the available test options that are out there. So when it comes to this viroid, the tests that are out there, the good ones are going to be specific to that viroid only. And that's important when it comes to something that's like, really this impactful. And that's kind of a hallmark of a lot of molecular tests that are out there. But there are ways to test for more things and in one go. So for example, there are these test strips that I was talking about, these antibody-based strips. Some of them can go almost all the way up to the genus level. So this test here is a tobacco mosaic virus, a TMV test that was developed for TMV, but it picks up the vast majority of the related Tabamo viruses. So it picks up the TOBRF, it picks up a lot more. So you kind of have to look into, number one, if you're looking to buy kits from providers, ask them for their validation data. Make sure that a provider can give you something that will fully characterize, here's what we tested against, here are all the things it does detect, here's what it misses or doesn't detect. And those validation reports will be able to tell you whether it's just one pathogen that will be detected or a whole panel of them. So hope that answers the question.
It did. It did. Do you have a basic guide that could help people understand again those steps that you just took us through?
Yep, certainly. We have some videos, we have validation reports, we have user guides, we have all sorts of guides that we can kind of put together and send this out as well to everybody here if they're interested in that. So definitely let me know. We've got information out there on the website about that,
Excellent.
especially at the QR code on screen. That'll bring you to the best spot for that.
Okay, I just saw that another question just came in. Let's just see here.
Sure.
Has TMV been found in cannabis with your immunostrips?
TMV anecdotally has been found or detected, but we'll put it this way. Since it's been detected by the immunostrip, maybe it's TMV and maybe it's a related pathogen. Again, since this can detect other related to BAMO viruses. The one thing that we don't know, we don't really know truly what the impacts are. We know that it can cause some symptoms, maybe mosaic-like symptoms, but again, that's not very well characterized yet. And so I don't know how much of a threat that is. I think it's only a matter of time before some Tabamo virus, which is the genus that TMV is in, before something like that crosses into cannabis, because they pretty much cross into everything. It's just a matter of determining whether or not it's really as impactful as something like the viroid.
Okay, great. We're all going to have to keep our eyes and ears open for that. Colin, appreciate the information. Thank you for presenting today.
Thank you very much. Enjoyed it.
And like always, you are right on time. So what we're going to do now, you might have to stop sharing, and then we'll bring up Andy Peterson. Andy, if you can share your screen.
I was just ready to do that, and then the button disappeared.
Like always.
Yep.
Okay. Typically green button down at the bottom of your.
Yep. I'm looking for it. Well, there it is. There we got it.
All right.
All right. That's
Thanks,
it.
everybody. Okay. So again, thank you, Colin. And we are now going to cut over to Andy Peterson with Verano 365. He's our second presenter today. And once you bring up your presentation, Andy.
Okay. I did. It didn't share.
It didn't share.
Okay. So I
You
don't
might
know
have to
from here.
You hit the green button, correct?
I did, and it came up on my screen.
Okay.
Now I'm trying to get out of the screen. Hang on. Can you see that? No.
No.
Can't see that. Okay, I'm sorry. I don't know how to open this up other than the way we did it just in practice.
Okay. Let me see if I can help here.
You.
Sorry, everybody. Just give me one more second. We'll go to our plan B.
I think, oh, you're going to bring up my presentation?
Yep.
That would be probably best.
And you'll just cue me on advancing the slides.
My apologies. I can try to share screen one more time. I got the button now. It's not coming up. Turn on my video.
Give me a second.
Okay.
I should be able to help us out here.
Yeah, I can try one more thing here. No, that's not going to work. I'm sorry, I had it up and running and I hit share screen and it did not share.
Yep. We will be good to go here in just a second.
Okay. I can start out with a little introduction of who I am.
Nope. Give me a sec.
Okay.
We're very close.
There we go.
Yep.
There we go.
Great.
Thank you, Greg.
So,
I appreciate the backup there.
You are welcome. Okay. It's all yours, Andy. And thanks for being here.
So I'll just cue you to advance then. Is that correct?
Yep.
Okay. So good afternoon. Thank you for attending here. My name is Andy Peterson. I am the national kind of sales coordinator for Verano 365. And we have a very unique product called Evo Factor. Like the first screen says here, profitable results in ornamental CEA and cannabis. First portion of this presentation is going to focus a little bit on my initial trials in ornamentals and then into CEA, and we'll close it up with how it all relates to cannabis. So if you could advance that, please. So Verano 365 is a subsidiary of a company called BPS Agriculture. And all of our products under the Verano 365 are focused for CEA ornamentals and cannabis. You can see the family of products right there: Evo Factor, Cultivata Organic, and Thrivedo. All of them have the Opus Max technology in common that kind of powers all of these. So we'll just skip around the horn here a little bit. Evo Factor is what we're going to spend our time with today, but we also have a superior wetting agent, both organic and standard, powered by the Opus Max technology that we'll go through. And then you'll see later on a variant of Evo Factor called Thrivedo, again, all powered by the same Opus Max technology. Next slide, please. Opus Max technology is kind of interesting. It actually comes out of the oil industry for fracking. It was used as an adjuvant to add to the chemicals that go into fracking water. So you drill a hole into the shale, you introduce Evo Factor enhanced or Opus Max enhanced chemistries into the drill hole, and you get a better penetration into the shale. And when you rupture that, you get a better yield out of that well because you've had a more complete rupture. So that's a little bit of the history. But before you can start pumping oil, you got to pump the water out of the fracking well. And because the Opus Max is an OMRI listed molecule, you can just dump it out on the ground. Well, they were wondering why the grass and everything else seemed to grow so much better in that effluent water. So that's kind of powered this discussion. And that happened about 10, 12 years ago. Fast forward to today, what is Opus Max technology? Opus Max is a charged silicon molecule. I have to be very specific here. It is not, some of you are probably nodding your head, oh, we've tried silicon, we know what silicon does. It is not meant to be a nutritional portion or a fertility portion. It is a charged silicon molecule that facilitates the self-assembling supramolecular structures. So an example of a supramolecular structure that everybody would be familiar with would be DNA, the double helix, the basic coding of life. We get two pieces of RNA that will come together and they click like a magnet. But instead of just staying bonded like this, they actually will self-assemble into what we know as the double helices of DNA. In Opus Max's case, we introduce this charged silicon molecule into a solution, and it creates, for lack of a better word, snowballs. And you can see that in the picture there. That's an artist rendering, but big snowballs. Next slide, we can show it kind of a real time what that looks like. So on the left, we have a solution in water. I believe this was like a 2010 20-year calcium nitrate or something, but it was a 1% active ingredient solution. Upon introducing, 15 minutes after introducing the Opus Max molecule, you can see how it creates these supramolecular structures by gathering these molecules around these kind of loose molecular structures. Opus Max is kind of a indiscriminate bonder, if you will. We'll come back to what that means, but we're going to focus now just on the fertility aspect of this. So when we introduce Opus Max into a fertility system, it bonds with the fertilizer, creating these supramolecular structures, which facilitates the nutrient passing through the cell membranes via osmosis. It tricks the plant, if you will, is a crude way of putting it, into absorbing the fertilizer more readily. It is also metabolized more freely. So when we do that, good things happen. Next slide, please. Greg, did you? Oh, there we go. So I got introduced to this through a colleague of mine. And he said, hey, we've got this stuff. You can introduce it into your fertility. It changes the fertility, and you can grow an ornamental crop with 50% less fertilizer. And I said, yeah, right. And he goes, you want to try, do some trials with it? I said, what the heck? So these are pictures from my initial trials. If you look, remember we talked about variants, the one with the pink flag right there. That is a product that we really don't even sell anymore, called Nutravix. Point being, it was one of those Evo Factor variants. But what we're going to start talking about and building is a common case and a common set of reactions that happen to plants in the presence of fertility enhanced with Opus Max. So the geranium tub there, that was the very first one I did. The difference in those plants is 8 days. So both they were run on the 2 different boom systems. One had the same amount of fertilizer, one enhanced with Evo Factor, one not. That picture was taken on day 8 after the first application. So you can see we get fairly rapid results with fertility that's enhanced with the Opus Max technology. Next slide, please. And again, here we see the second kind of generation 2 testing, producing the same, or actually in many cases, a better plant, utilizing less fertility, as long as it was enhanced with Evo Factor. Next slide. Okay, that's great for big plants, but what about young plants, things that are very sensitive and very easy to get out of control? These were 288 flats. We're not going to go into what they are. There's a chart that you can take it apart later here if you want to revisit this. The bottom line is these young plants, which are very sensitive to fertility, either too much or not enough, were actually grown, got the same results with 50% less fertilizer. That's very hard to do. This told me we're really onto something that is a tool for managing fertility, particularly in ornamentals. Next slide. So we did some testing. This was just some treatment weights. We highlighted the tomato one because that one kind of jumped out at you. If you read across, the Evo Factor enhanced plug tray actually grew more plant tissue with 50% less fertilizer. And my big tag word here is you shouldn't be able to do that. In fact, I've developed an entire talk based around that. Again, this is kind of building the case here again. Whenever we introduce Evo Factor enhanced fertility, we get enhanced plant performance. Next slide, please. And so the next step is CEA. What do we see in CEA? Well, we saw Evo make everything better in ornamentals, but what does it do for us in agriculture? It's great to produce more flowers. Producing flowers is more about producing the same product, the same end product with less input. Agriculture, CEA, agriculture in general, is about producing more with the same input. Okay. So yes, so the answer is we'll scroll through these CEA slides pretty quick, but you see the trend. Next slide, please. Arugula, you're seeing better root, better top development. See in the bottom left corner, 20% more fresh weight on a hydroponically grown arugula. Next slide. we can just blow through these pretty quick, but it's, again, another Calipro forma. The first one was Jax. This is Calipro. Let's be clear. Opus Max EvoFactor does not care what the fertilizer source is. I come back to the equal opportunity bonding aspect of Opus Max. Opus Max has a batting order of elements in which it prefers to bond with. It tends to bond with lighter elements first. We'll get to that a little bit toward the end, but just be advised, it doesn't matter what if you're dealing with base elements, if you're mixing your own fertilizer, if you're using pre-mixed bag fertilizer, if you know the nitrogen content of a hill of manure that you're about to make compost tea from, this stuff doesn't care. I'll calculate a rate and it will work. Next slide, please. Again, across the board, plus, all the way across the board, every time we enhance it with EvoFactor. Next slide. Here you can actually see the physical growth and the more plant tissue growth. In fact, in this one particular study, we got 110% of the mass using EvoFactor enhanced fertility. Next. That's great about top growth in lettuce, but what does that translate into fruits? Well, look at the lower left. You can see 200 parts per million EvoFactor. It crushes the harvest of the just straight 200 parts per million non-EvoFactor enhanced fertility. Next slide. Again, we're seeing the trend. We're getting so. Bottom line here again, on arugula. I keep coming back to arugula. We did a lot of work with that because it grows really fast. 26% increase in yield. So if you look at a greens grower, that's getting 3, maybe 4 turns a year on that square footage, we can come to that microgreen grower and say, how'd you like to turn that space one more time in a year? Now we're talking about profit. Again, we're seeing that trend that carries across from ornamentals to CEA. Next, please. Now, the heart of the matter. This is why we're here. Cannabis. Cannabis is a plant. It is nothing special. Unless you're making your living from it, but it is a plant that is subject to all of the rules of biology, physics, chemistry, physiology, all these things. They all apply to cannabis. What do we see when we introduce Opus Max and EvoFactor into cannabis production? We should see the trend continue. Next slide. And we do. These pictures were taken this late summer with cannabis crop grown, I say out east. Everything out is kind of out east from the Midwest, but you can see the quality of the crop. We see better and typical. We see it in agriculture crops. We see it in ornamentals. We see better roots. We see better stem caliper. We see better plant tone, overall plant health, all indicative of a plant that is getting sufficient nutrients. Next, please. So while I'm a little short on pictures of cannabis, I'm a little short on tables of what of cannabis Opus Max treated crops are. This is the one I was able to retrieve. And again, look at the top there. It says Thrivedo. Thrivedo is, for our purposes today, basically EvoFactor that carried a cannabis label on it. And EvoFactor also carries cannabis on the label. There are slight differences, but the driving force behind both these products is the Opus Max technology. Again, we just highlighted that trial number 4, Gorilla Glue. You had a 47% increase in bud. And the average yield increase across all 7 trials of 36.7%. Naturally, you find what you're looking for about the time that you can't put it into the slideshow anymore. I came across a sheet that we did in medical cannabis with some results on it, and I can make this available offline again, anybody that wants to access this. And this would be all, I believe this sheet will also be on our Verano 365 website. But in the medical cannabis, we saw an 8.5% increase in cannabinoids, an 8.5% increase in THC, and an 8.7% increase in terpenes. And that's just by adding Evo Factor to comparable levels of fertility. So, like I say, Evo makes things better. Opus Max makes things better, particularly when it comes to fertility. Next slide, please. This technology is incredibly user-friendly. There's an Evo Factor application guide. The chart is set up quite easily, and I'm going to try to focus very much so on this application chart, but also the statement of Evo Factor's performance is scalable to any size growing operation. I say it again, any size, whether you're big or a homeowner. This is scalable technology that will work for you. So if we look at a premixed bag of fertilizer, our left column is the first number on the bag, nitrogen. And this is where I'm going to come back to our batting order and molecular weight. Evo Factor likes to grab onto those light molecules first. That's why we use nitrogen. Don't get too fixated on nitrogen, other than when it comes to Evo Factor in this chart, it is our measuring stick. It's how we determine how much Evo Factor to put in with a given amount of premixed fertilizer. So if I'm using a 20, 10, 20, I go down to 20. That's my first number. I go to the right column and I will use 17.5 fluid ounces of Evo Factor per 25-pound bag of premixed fertilizer. If you're mixing your own, you're using a Part A, a Part B system. Again, for Opus Max is the equal opportunity bonder. Evo Factor doesn't care what the nitrogen source is, and the nitrogen, again, is our measuring stick. But if you look at that little block in the upper right-hand corner, it says 3.5 ounces of Evo Factor per every pound, actual pound of N in that stock tank. Okay? If you look at the block to the upper left, it says, and this is very, very important, allow 15 minutes for the reaction to happen. Once that reaction happens, those bonds never go backwards. They don't outgas and they don't settle out. Okay? It is an incredibly stable solution over time. It's really not that much affected by heat. It doesn't seem to be affected by freezing, not that you're going to freeze your stock tank. It is awesome for like flood irrigations or common well hydroponic systems, because it is so immensely stable over time. Comes in 2.5 gallons, 55 gallons, and 275-gallon totes. Again, it is scalable, and I can't emphasize this enough. It is scalable to any size growing operation. Now I want to spend just a minute on, remember we talked about the properties of Opus Max being kind of an equal opportunity bonder. I've got some anecdotal evidence that is strongly showing an increased effect when Evo Factor is used with any humates or fulvic acid. Fulvic acid, it seems to make both complement each other extremely well. We have some anecdotal and evidence of Evo Factor being used with biological control agents, making microbes better. We don't know why. These are anecdotal occurrences. We don't have anything replicated, but the growers that start using just a little bit of Evo Factor in their applications with biologicals tend to see a lot better things going in. This is purely my speculation based on nothing more than a educated guess. Is some of those biological control agents rely on released antibiotics or secondary metabolites to do the heavy lifting. We think that evofactor may be bonding with some of those secondary metabolites or some of those antibiotics or exudates and actually making them better. And when you look at the amount of evofactor you're using in a gallon of water, we kind of refined it down with BACs down to like 1 mil in a gallon of water for a spray or a BAC application. This stuff works at incredibly low rates. It is Opus Max in fertilizer. It does not take much Opus Max to light your fertility program up. Next slide, please. This is what happens when you use Evo every day. You get to be an old fat horticulture guy. Myself, there's my contact information. The guy who is my the inside coordinator for us nationally, this guy named Len Wall. He's another guy you can get a hold of. I strongly suggest you call your Griffin sales representatives. Those guys are real experts. They're very good at what they do. I'm sure I've generated a ton of questions because this is something that's really new. It does things that I come back to it. You shouldn't be able to do what we do with the teeny little volume that we add to it to get that level of enhancement, that level of ROI. When you look at in Minnesota, that's where I am right now. We just decriminalized cannabis in our state. And if you look at the trends in other states, we got this big boom and then there's a consolidation of the business. If I can show you a way to produce more or higher quality out of the same inputs in the same footprint, I would hope that would give you a little bit of a competitive advantage over those that aren't diving into this. And Greg, your slide's the last one here. You can go forward.
Yeah, before I move on to that, Andy, and I hope you're hearing me okay.
Yep.
I've lost visibility to the chats, and Rebecca has shared with me that there's at least one that's come through, maybe more. So
yeah,
Rebecca,
I saw a couple of them bounce up.
Yeah, if you could read those off, Rebecca.
Sure. So one of them was, this is very interesting. Is the product considered a growth stimulant or a growth regulator?
It is neither. It is labeled as a fertilizer adjuvant or an additive to the fertilizer content. We're not going to go down the PGR route. Number one, we aren't a PGR. We are something that enhances the fertility. So it is officially a fertilizer adjuvant, not to be confused because there's about 1 million fertilizer and other adjuvants and wetting agents. This is not a wetting agent. Okay, it's not a typical non-ionized surfactant or something like that. There's nothing like this stuff. We've got like 12 patents pending on it. This is the only thing like this in the world. So to answer your question, in short, it is not a PGR or growth stimulant. It is a fertilizer adjuvant. We are enhancing fertility.
Awesome. And then another question that came in through Q&A is, does evofactor work the same in raw soil core, cocoa coir, or soil in aquaponics?
The bottom line is, any time enhanced fertility is desirable to increase plant growth, plant quality, or increase yield, evofactor will work. It doesn't. The substrate is irrelevant. It doesn't matter.
Okay. And then the other one was with microbes and BCAs. So I guess you answered that too.
Oh, about what was it about BCAs?
With microbes and BCAs.
Yeah, sure. Now, by BCA, I'm going to take out the macro BCAs. Okay, it's they don't the beneficial mites and stuff. They just don't care. It doesn't bother them. In fact, the enhanced fertility, growing a better quality, healthier plant will actually make your macro BCAs more effective because they just don't have to work that hard. The microbial BCAs, it's strictly anecdotal, but I've got several growers that'll, it's a milliliter per gallon. It becomes a why not, but it seems to enhance the efficacy of those microbial products. Now, is it that we've created a healthier plant because we've got better fertility? Maybe. But for the cost of almost nothing, you know, milliliter per gallon is, I don't even want to put a price on it. It's hard to calculate.
And then one more says, are there any chemical signatures or residuals that can be detected in finished product?
The answer is I don't know. Okay. My guess is, if I had to give an educated guess, is no, because it's bonding with the fertilizer, it's being assimilated and utilized within the plant tissue. What I will say is coming very quickly is the organic version of Evo Factor. The Opus Max molecule is already registered with EPA as an inert, believe it or not, an inert ingredient, but it is OMRI listed as organic. It's the other stuff that we got in the standard Evo Factor that is not going to be OMRI compliant, but we do have a finished OMRI Evo Factor that is in testing stages for us now. So right now we're just evaluating rates. The usage pattern would be the same. We're just trying to determine whether the rates would be the same as the non-organic Evo Factor. But to answer your question specifically about residues, I just don't know. That's something, Greg, that I can get back to you on and get some sort of idea on that.
Yeah, please do, because
I'm just going to take a note here.
Yeah, if you could please do that. We are the distributor for this product. We are stocking it. There's a lot of interest. I think with your presentation today, Andy, there will be even more interest in this product. I think that it ties in very, very nicely to the theme around efficiency. So if you're doing something faster, better and faster, that really connects directly with our theme behind efficiency and how our industry, cannabis, needs to become more efficient in every way possible.
If I could add just one last thing here too, while this is still new technology, it's been available on the market for 4 or 5 years. We are now, and I have to go back to my ornamental roots, we are now seeing a buzz at that large grower level that's in a box store, highly competitive, low margin, high volume guys that are taking this technology and putting it to very profitable use. Word is starting to spread kind of peer to peer there about the results that they're seeing and the amount of money that they are able to economize out of that production. I anticipate that it seems to follow in every other thing. Again, wherever fertility enhancement is a good thing and desirable, you're going to find that this stuff shines.
Great. Thanks, Andy. Rebecca, is there one more question?
Yeah, so the other question is, can you use foliar application with nutrients?
Okay. Opus, this is one thing, I'm glad that came up. Opus Max by itself does nothing. It needs a dance partner. All right. In the majority of this presentation, the dance partner has always been fertility. Okay. Opus Max in a foliar application or a drench application basically won't do anything. All right. Once it's come in contact with the dance partner, fertility, it will bond with that fertility and enhance it, or it will enhance whatever it comes in contact with. I've got some anecdotal information on plant growth regulators, on herbicides, on insecticides, it's all kind of out there coming, but the bottom line is Evo makes things better. As a standalone product, it really doesn't do anything. It needs a dance partner. So if you're going to go into a foliar, you got to have some sort of fertility with it.
So does this product also affect pH at all?
No, not at all. You can add it directly to your stock tank, we call it a stock tank or nutrient solution, without affecting pH. You will, like I said, there'll be no outgassing, there'll be no settling, there'll be no adverse chemical reaction. The label says agitation. Well, that's like, one stir with a stick, and that's about it. Even if you don't agitate it, the stuff disseminates across the whole profile of the solution.
Great. Before we go to our final slide, I just want to make sure there's a lot of great questions that have come in. Is there anything else, Rebecca, that we've missed?
One about the product being permissible by the CCC in Massachusetts. We can check that.
That's a specific one we'll have to dig up. And
Yeah.
I guess I didn't quite follow that. Is it specifically able to be used in Massachusetts on cannabis? Is that kind of the gist of it?
Correct.
Yeah.
Okay, that one I'll have to check on. I'm pretty sure it is, but before I say yes, we'll get a firm answer on that, and I'll put that down with the follow-up.
Great. Yeah, everyone that's on the webinar, on these presentations today, will get a link. Give us a couple of days. We'll send out a link to the to both webinars, and we'll make sure that we get all the questions. If we missed one in any of the chats, we'll make sure we get them answered. What I'd like to do is just to make sure that I spend a brief minute on this slide. For those of you that maybe don't know Griffin, but are participating in the webinar series, our CEA division, we service the country through a nationwide footprint of warehouses. We have 15 across the country. We are independently owned and have been for the last 76 years. We really focus on providing reliable service and generating a collaborative success. We want to work with you. We have a strong network of sales reps that are out in the field covering the country. And we're excited to work with you. We're excited that you're part of this webinar, and hopefully you will participate in the 2 remaining webinars after today's. There's our contact info. We really appreciate your attendance. Please know that it is greatly appreciated. Thank you, everyone.